it's a different area lah. So if you want to become an expert in circuit design, normally people focus on one ni lah. Yes. Ada soalan ke? Tak ada. So on the fabrication part, is involved chemical.
Tapi Pak.
Harap kawan lain dapat membantu Muhammad Adam. Alright, so we have 51. I think we can start now. So that just a little bit about Nila, knowledge you need to know about this subject lah. So hopefully you know lah what you're going to learn in this subject. So I'm going to go to chapter 3 straight away. So before I start, is there any question? Ada soalan tak nak tanya? So semua boleh refer ke lecture notes Boleh nampak tak lecture notes saya?
Nampak.
Alright, so first before we go to the CMOS part, when you have to design circuit you have to represent it lah. So you can have like standard way 3 domains lah. You can have when you want to design something or a system, you can have circuit. You can come out with a behavioral, maksudnya you punya circuit punya output lah easy way. Or you can come out with a structural. Structure in this case for circuit is a schematic lah. Or you can come out with a physical Physical maksudnya fabrication process. So you must remember for this subject, this is about IC design and process. So you're going to learn about little bit lah, not too much about IC design. If you learn about analog IC design, that will be inilah lagi panjang cerita. This is about digital IC design. So the difference is when you design circuit in digital, you just use transistor lah. So everything will be on off or 0 1 or high low. So you can come up with a behavioral, so dia punya characteristic. You can come up with a structural and come out with physical. So each domains are specified at a variety of abstraction level. So dia punya level is different. I think I can share you the side image how can you have a different level of abstraction lah. And it depends on your design and your circuit complexity lah. If you're going to design a NAND gate you shouldn't have to do that lah. Now but we are talking about big circuit lah, for example microprocessor, or maybe let's say adder lah. Adder, you have to design adder using CMOS technology maybe. So that one you need to have a behavioral, so means that when you have this input, what are the outputs, and of course you must have a schematic, and you also must have a physical, the process, how you're going to fabricate it. So design a circuit is one thing. Now fabricate is a different thing, totally orang kata apa, different knowledge lah, different part area. So this is we conclude this one So any design you can present it, each of them in 3 domains lah. So the first one is behavioral. So if you ever learn about HDL language, this is kind of the code lah.
Doktor.
Yes.
Sorry, ada lagi request tengah pending nak masuk MS Team.
Okay, saya dah accept all. Okay, so you can have behavioral. So these three keywords are very important lah. What is the meaning of behavioral? What is the meaning of structural? And what is the meaning of physical? So if you look at the slide, page number 3, there is a diagram lah. I call that stick diagram. I think for structural circuit circuit punya connection I think it's not something new for you lah. You have to learn about circuit. So this is a structural schematic circuit schematic. behavioral, if you learn about HDL before, this is the way how you write the code lah. And then physical, I think this is a new thing for you guys. So you can have a diagram. We call this one stick diagram. Stick diagram is one way to represent your physical lah. So physical ni normally akan involve dengan masking. You boleh imagine, I think for your understanding, you must understand about PCB lah. When you want to design copper copper nak macam mana bentuk dia. So there is a limitation lah. Let's say if you want to make it 1 micron, sometimes it won't work lah. This is because of lithography, about process. So let's say if you want to design a transistor, you must know what is the minimum width ataupun what is the minimum line tu yang you boleh buat. Otherwise, maybe you need less than 1 micron for specific reason lah. But unfortunately, the technology, maybe if you're using this technology, it's only up to 1 micron. So if you still need something less than 1 micron, it's either you're going to use different technology atau different machine, or you have to do something lah to make it works. So we call this one stick diagram. So when we have like so many transistors, you have to design. So you can simplify it using this stick diagram. So in chapter 4, I think this is the main content for this stick diagram. Okay, so for behavioral, what is behavioral representation? So you're going to present the behavior of your circuit design. So it describes your particular design, how it should respond to a given set of input. So the easiest example is about let's say we're talking about NAND gate. When we have 2 input, for example, or 3 input, A, B, C. So when it is 0, 1, 0, what is the output? So this is kind of behavioral. So this behavior is normally specified by Boolean equation. So you have learned about this before. If you realize, there is always continuity. What you have learned before, I think in digital electronics. So you're going to apply it in other subjects lah. And then you must know about truth table lah. So from truth table, you can represent your behavioral circuit or algorithm, or if you learn about HDL, I'm not sure lah. I think in other subjects, you can learn about HDL lah. This is also good for IC design. So Verilog HDL describe the behavioral of circuit. So dia akan describe lah what is the output. And all this is required for specification and verification. So if you design a big system, you need to specify and verify it. Is it the real thing that you need for this system, for example. And normally, if you're going to design a NAND gate ataupun inverter, so you don't need this one lah, because it's too. This is when you're talking about big circuit. And of course, structural. It's describe how the circuit are interconnected. So the schematic diagram lah. Transistor tu you have, if you learn about CMOS, you have the pull up, pull down. After this we go this one. So yang belah atas tu P type and belah bawah N type. I believe that you should learn about this in chapter before lah. You can have transistor, MOSFET. It can be N channel MOSFET or P channel. So some people call NMOS or PMOS lah. So this structure are specified by schematic diagram. So you can simply drag and do the connection lah. So you can show the interconnection of circuit element. So you can also have a netlist. If you learn about HDL, you akan ada satu file, we call that netlist file. So that can represent the structure representation. So that one, when you use the netlist, you cannot do the design by dragging lah. So that one is very hands-on lah. Maksudnya you tarik transistor, you letak satu atas P, bawah N, and do the connection. You can become inverter, for example. But netlist, instead of doing that one, you are typing. You're typing coding. We have one transistor pull up, one transistor pull down. What is the size to it, and then you can get output. So this is structural representation. So it is required. For realization of behavioral model. abstracted from a process. That's why when you design a transistor ataupun a system, depends on technology or process. Let's say if you're using 0.13 or you're using different, I think dulu orang guna 0.18, but now your transistor shrinking, your transistor becomes smaller. So you can have a different technology lah. So that's why you need to do the ni lah simulation first. So normally when you have a smaller transistor, yeah, it's good lah. You can have a thinner ataupun small device ataupun light device lah, because on the same area you can have more transistors. When you have more transistors, you can have more function. So lagi powerful lah you punya. You can become, let's say when talk about processor, you can have a very powerful microprocessor. And in terms of current usage and so on, you can have lower current and fast switching. So in general, the structure representation is derived from the behavioral. So when you want to design structure, you always refer to the behavioral because behavioral itulah output yang you nak. So you're going to design a structure depend on the output that you want. Alright, so just for your information, you know, nowadays you're always working on software, but long time ago, I think in 1960s something, when you have to design a microprocessor or part of microprocessor, you have to draw it on a big paper and you do the connection. That's how it was, because that time computer pun tak advanced lagi. You don't have all this software, you have to do it manually. And due to that reason, there are so many mistakes. But nowadays when you do connection and try to run, you got error. Oh, rupanya lupa satu connection, nak connect ke ground for example. But dulu tak ada lah. So nowadays it become very convenient. It's easy to become designer, not like a long time ago. Okay, next is physical representation. So it is used to define how your particular part has to be constructed to yield a specific structure. For example, you have a transistor, MOSFET, and N-type and P-type. So you have to consider that in your mask, because N-type you have to implant, let's say for N channel, you need to have a source and drain, which is you must have a P substrate. Your source and drain must be N plus. So, but if you have a same different transistor on the same area, so you have to make it different lah. Let's say for P channel, it is the other way around. So you have to define it physically. It's easy to do for one transistor lah, but if you can imagine when you have like 1,000, it's very complicated enough lah for you to design a mask. Okay, so stick diagram. I've mentioned about stick diagram, so you must familiar lah. What is stick diagram in Malay? Forgot lah. Something lidi lah. So it shows the relative positioning of circuit element and wiring. So wiring maksudnya connection lah. So normally physical representation, you have to design your mask. Before you do your fabrication, you must have a mask. Kenapa you nak ada mask? You nak ada different this part you want to cover, because when you have to fabricate a transistor, you always need to cover this part and you don't want to cover this part. So you're using mask for all the fabrication process lah. Okay, so this is memang takes time and to design is not easy lah. Okay, that is how you're going to represent your design of circuit. So now, before we go to our schematic, you must understand that in this subject, I think you might refer to online, but don't get confused. You can find, let's say for your assignment, you can find any circuit, but it has to be a CMOS. So some students, when you ask to design any circuit using CMOS, they just come out with one type of transistor, which is N channel, for example. That one is not CMOS. CMOS must complement, maksudnya ada P and N at the same time. So there are reasons. The reason is, I think if you Google, you can find it, but it's either you understand or not. Because if you use CMOS, the good thing is you complement. Maksudnya dia actually nak conclude, nak senang cerita, dia lebih jimat current. Maksudnya consumption current, leakage current dia kurang, because you only use when you turn it on and when you don't use it, you turn it off. So leakage current very low lah. So you can have low power consumption devices lah. That's very good. So what is CMOS? I believe that we have learned about MOS before. MOS is metal oxide semiconductor. So metal can be aluminium, oxide is normally silicon oxide, but nowadays we have high K materials, can be any metal oxide. And you also have semiconductor. So semiconductor is normally silicon, but nowadays people are working on like so many materials. You can have like silicon carbide, you can have silicon germanium, you can have germanium, you can have there are so many materials. So, but in your subject, just focus on silicon. So it is complementary metal oxide semiconductor. So the word complement, I think you have used that word, especially when you need to complement each other lah. So complement, you tahu maksud complement. Let me ask someone. Aina Bahya. Aina Bahya ada tak? Tak ada. This is the problem with online class lah. Sometimes when you give a lecture, you're talking to ni lah, computer yourself. How about Akmal Daniel? Tak ada juga. Arifin bin Herman?
Yes sir.
Oh, I forgot to record the class. Someone ada tak? Okay. So you can share the link to those who cannot attend this class. So since saya tak tahu siapa record siapa yang record tu boleh ambil link lah. But I think from the team sini you boleh refer back lah. Okay, siapa? Akmal Daniel ke siapa tadi? Arifin?
Arifin tadi.
Arifin okay. Arifin bin Herman. Okay, so you know what do you understand about complement?
Complement tu dia macam dua pair transistor, dia pakai dua pair transistor tapi satu yang switch on, macam ganti-ganti switch on.
Okay, that one is on the ni lah. I'm asking you about complement in definition of complement. Have you used that word before?
Complement untuk bagi pujian dekat orang. Complement.
Apa dia?
Untuk bagi complimentary lah dekat orang, macam pujian.
Pujian Okay lah, depends on ni lah. Maksudnya compliment ni you saling memerlukan lah.
Okay.
So it's very good words lah you have to learn. So let's say if you want to propose someone, so you can we need to compliment each other lah. So normally suami isteri, you kena compliment lah each other. Maksudnya dia boleh buat ni, tak boleh buat ni. Or maybe best friend lah dia kurang ni, dia lebih ni. So in this circuit, kalau N channel tak on, P channel akan on. That is the mean of complement. Boleh?
Boleh sir.
Faham Hopefully yang lain faham So kalau tak faham tu, you boleh google lah what is the meaning of complementary. The fact that the design use pairs of transistor. So kalau saya kata, okay, design any circuit lah, the simplest CMOS circuit. You cannot come out with one type of transistor. So you have come out with at least two, a pair of transistor, N type or P type, which is inverter lah. So when you try to make it function, one of the transistor will turn on lah. So that is the meaning of complement. So you cannot have, if you're using CMOS technology, you give one input. So you cannot have both N and P channel on at the same time. That is the unique thing about CMOS. So only at one time salah satu je akan menyala. So you can get what output lah from there. So the phrase MOS, I think I don't have to talk a lot about this one. So I think chapter 5 we akan learn a lot about fabrication process. There are so many steps that we have memorized lah, kena hafal. And then you can also learn about the effect lah in reality. So the process created untuk field effect transistor. So since you learn about MOSFET, normally we use metal gate electrode on top of oxide insulator. That's why you call MOS lah. Okay, so this is CMOS circuit. If you go to next slide, slide 8, complementary CMOS. So it consists of N channel network and P channel network. So this is very important lah. Because I think it's either in your test or your final exam lah. You're going to ask you what is CMOS. What is the meaning of CMOS? Can you explain lah? What is the general structure ataupun CMOS tu apa benda lah katanya. So you must have N channel and P channel. You akan ada group of N channel, group of P channel. So N channel is between output and ground. Nanti saya akan tunjuk figure lah, lagi nampak kalau you tengok ayat ni you tak faham kalau you ada figure lagi senang faham. But anyway, you go through this one first lah. So it also known as NMOS, pull down network. So belah bawah tu kita panggil NMOS pull down network. And then you can also have P channel above. It is between your output and VDD. So it is also known as pull up network. PMOS pull up network. So you punya input, you're going to have inputs. It can be more lah. It's not only one. It can be more than one. They can go to both networks, which is N channel and P channel. So the means of complementary here is, let's say when you have a parallel component on the N channel, let's say kalau ada komponen the bersiri, you punya P channel akan jadi selari, akan complement. Ataupun kalau dia parallel, and the other one akan jadi series. Okay, that is the meaning of complementary in CMOS. Satu lagi. I think if you go to this one, the general structure of CMOS logic gate. So you can have, let's say in this example, you have three inputs, VA, VB, and VC. Above atau on the top, you can have VDD, ataupun power supply lah, ataupun voltage. And you can have a ground dekat bawah, which is connected to N channel network. So complementary P channel network adalah N channel network kat bawah tu lah. So you can have P channel above and channel below. So this is the general structure of CMOS logic gate. So before you go to schematic, there's one thing that you need to know. I think you have learned about this before, like many times. You know that transistor can act as a switch, in ideal case lah. So what is the meaning of that? Macam mana nak sebut? Evelyn Lori.
Ya, doktor.
Okay. Do you know that transistor can act as a switch?
Tahu.
Okay. Can you explain that one?
Kejap saya susun ayat.
Okay. Nak Google pun tak apalah.
Dia macam logic gate. So bila kita bagi input tu kosong, so dia off. Bila satu on, macam tu lah. Okay, saya try.
Yalah, betul lah tu dalam slide macam tu. But orang kata apa, you punya understanding, first you must know lah, I believe that from previous subject, you have learned about transistor can act as a switch, but can you prove that ataupun can you explain that? And this is very important lah, because transistor act as a switch. Can you imagine you ada like 1,000 atau million transistor in microprocessor, so macam mana dia act as a switch? So first thing you need to know, siapa tadi? Evelyn. For transistor, you ada berapa terminal? For MOSFET lah senang kata.
MOSFET?
Dia ada berapa kata apa, berapa kontak? Berapa terminal, berapa kontak? You need to know this one.
Ada 3.
Okay. What are they?
GDS.
So G stand for?
Ground, gate, D drain, S source.
Okay. Apa yang faham tiga kontak tu ataupun tiga terminal? Apa tadi? Evelyn. Apa yang faham tentang gate, source and drain?
Yang saya faham dekat drain tu macam ada current connection dia. Jadi
Macam mana?
macam ada current connection dia.
Okay, so how transistor can act as a switch? Can you explain using gate, source and drain? Boleh? Sementara saya mencari pen saya ni. So current flow from
Source
to source tu dia pergi ke mana?
apa?
Daripada source dia pergi ke?
Ke gate, lepas tu pergi ke drain.
Pergi ke gate. Are you sure?
Ya. Ke tu
So,
bang?
macam mana dia boleh jadi switch? You need to understand this one. This is very important. Boleh explain ke tak?
Kalau dalam proper word saya tak pernah explain.
Apa?
Okay, sorry doktor.
Nanti you balik, you study balik macam notes. So
Okay.
kalau saya punya ni, boleh nampak ni tak? Apa nama saya punya whiteboard?
Boleh.
Nampak So I'm going to draw dia punya sini. Okay, transistor. This is very important ni untuk faham lah. Kalau you belajar tak best, tak faham. This is one simplified transistor lah. So you have gate, you have source, you have drain. Semua tahu Okay, so macam mana dia act as a switch? Sorry? Tak dengar lah cakap apa?
Share lagi sekali screen.
Share sekali lagi screen. Oh, tak nampak?
Nampak.
Boleh nampak tak?
Sekejap, loading.
Loading, okay.
Okay.
Boleh? So this is a MOSFET lah. So you can have metal here. This is metal layer. Actually very thin though. Dia dalam 1 micron. Sorry, 1 micron. Around 100 micron. And then you can have oxide at the middle here. And then this is semiconductor lah. So this is gate, source and drain. So how transistor acts as switch? this is semiconductor. So when you talk about semiconductor, you need to understand about physics lah banyak. Physics, about the depletion region. So let's say here, you boleh samakan dengan, you tahu stopcock tak? Pipe punya stopcock. Macam ni lah. Okay, so this is gate, this is source, this is drain. So connection source dengan drain ni depends on your circuit lah. If you're going to make it inverter ke apa, dia tengok is either connected to ground ataupun is either connected to VDD or is either connected to output lah. So by default you nak flowkan lah, air ni akan flow so, dari source ke drain atau drain ke source So when you talk about schematic ni, source drain tu doesn't matter, dia sama je. When you fabricate it, you tak ada fabricate ni untuk source, ni untuk drain tak bila you fabricate dia adalah identical dia tengah ni sama ni. So source drain tak kisah dia sama je. So sekarang ni kalau stopcock kepala pipe ni, you nak turn on, turn off salah, pusing kiri, pusing kanan, betul tak? But in this case, transistor, you act as a switch, you boleh main voltage lah. So let's say, when you talk about this is P-type for example, P substrate P substrate. Kalau P substrate dia akan jadi N channel. So your semiconductor adalah P. P majority carrier adalah apa? Hari. Just in time, memang skill awak memang buat benda ni kan. Hari Vincent.
Yes, doctor.
Okay. When you have a P substrate,
Yes.
you keep PSM on transistor design kan? Using Silvaco tak?
Yes, doctor.
Pasal panel okay. Sorry I have to ask ni, and you are the right person to ask. So what is the majority carriers in P substrate?
Majority carrier. Wait, doctor.
Dia sama ada elektron atau holes antara dua je.
P substrate electron.
Majority.
Majority.
You ada substrate. Substrate ni maksudnya silicon lah, silicon wafer So majority dia apa? You masuk P apa?
Holes.
Okay, holes kan. So majority adalah hole
Holes, yes.
Okay, so your minority carrier?
Electron.
Electron So this is your minority.
Yes.
So when you give voltage this is for N channel we take one type dulu lah kalau ni confused. So when you give let's say positive voltage dekat gate letak positive, you akan attract electron.
Yes.
Which is minority yang sikit dalam tu kebanyakan dalam P substrate tu adalah holes. So kita panggil P type So when you nak kena cerita dari awal dulu, kalau you ada semiconductor, this is semiconductor ataupun wafer silicon yang pure, dia sama, P dengan N sama, majority you ada wafer tu yang let's say ada 100 hole, elektron pun 100, so dia neutral. But if you add impurities, you dope ganda ataupun you implant, you boleh jadikan dia N ataupun P. Can be N ataupun P. So in this case, we're talking about P substrate. So P substrate majority adalah holes, and the minorities are electrons. When you give positive voltage, yang akan attract apa? Hari. Hari. Ya, you ada tak?
Yes, doctor.
So when you give positive voltage.
Sorry, my line is a problem.
Oh, okay. Never mind. So when you give positive, at least answer this question lah. When you give positive
Huh?
voltage, what will happen? What will you will attract holes or electron?
Positive voltage, we attract electrons.
So you will attract electrons, right? So that minority akan
Huh?
go to just underneath your
The
ataupun kita kata dekat
yeah.
surface lah. When you learn about transistor, actually banyak diorang explain on the surface lah. So electron akan kumpul kat sini. So whenever this happen, so your transistor is on. Okay?
Yes.
Oh, sorry, on. So that means the current that you apply from source to drain akan flow. So that's why you call this switch, a switch. Kalau you tak bagi voltage, dia akan turn off, electron akan go away. Ataupun when you give negative voltage, you akan tolak electron, you akan letak yang datang akan ada holes. Holes maksudnya, okay, source you punya source dengan drain ni, I forgot to mention, it is N plus which is electron. Banyak sangat electron ni, tak sabar nak keluar ni. But whenever you give positive, electrons ni dah jadi jambatan, dia akan jadi bridge, semua boleh pergi ke sini. It's either you nak go to the left or to the right, depends on the source dengan drain ni punya input . So normally from source lah kita apply, go to, so now barulah air tu mengalir, pipe tu mengalir. This is how transistor act as a switch. Boleh? Hari faham tak?
Yes, doctor. And
Okay. So this is, now we're talking about NMOS, which is N channel . But the other way around is for P. Kalau P dia terbalik pula. You bagi positif, dia akan turn off. Not turn on. So this is actually a MOSFET can act as a switch. So it depends on the voltage that you apply lah. So voltage get control the path from source and drain. So your gate input is very important because dia akan tentukan sama ada electron can flow from source or drain. Okay, so untuk PMOS ataupun P channel pula, dia sama, konsepnya sama, same thing, but you're going to have an N substrate, ni N substrate, and you're going to have a source and drain, tapi dia adalah P plus. Just now tadi N plus, dia P plus, so you can have an oxide and gate lah. So explanation dia sama lah. When you give negative voltage, so since N substrate majority adalah electrons and minority adalah holes. When you give negative, holes akan pergi ke sini, and you will form a, we call that channel actually, like a bridge that allow the the holes from source go to drain. So this is source, this is drain. So this is how you turn on your P channel ataupun P MOSFET. So when you give same voltage on P channel and N channel, both tu akan either on or off. Dia tak akan dua-dua on. For example, if you look at the slide on page page berapa ni? Page 10. You nampak lah, kalau NMOS you bagi you punya G gate 0, dia akan turn off. Maksudnya 0 ni bagi low lah, means low, dia akan turn off. But if you give G equals to 1, maksudnya you bagi positive voltage, dia akan turn on. But what happen to PMOS, terbalik. When you give 0, actually G0 is not a good way tu lah. Sebenarnya you kena bagi negative nak kata low je lah. Low dia akan turn on, but if you give high, dia akan turn off, dia terbalik. Is it okay, low P sin? Low P sin?
Yes, Papa.
Can you understand?
Yes.
Okay, any questions so far?
So far is okay.
So far okay, tak ada soalan Alright, so next, apa dah? It's around 11. Okay, after this kita ambil rehat around 5 minutes. Now we go to inverter. So this is very important because if you understand about inverter, you can do the rest lah, because after this you're going to do NAND and NOR again. Alright. Low pay, Sin, can you still see my slide? Oh no, not my slide, my whiteboard.
Yes, Doctor.
Okay, even I move my whiteboard, you still can see it. So let's say you have inverter. So you know what is inverter, right? It's not about aircon inverter, any inverter and transistor. You can have input A, and you can have output. Can be X, Y, whatever lah. So for inverter, in this case you have one input. Okay, this is a symbol. You can see. Now we're talking about slide 11. You can have inverter. Cantik redraw balik. Inverter, this is a symbol. You must have, you must put the bubble. Don't forget to put the bubble during your exam. Some lectures akan bagi salah terus. So you can have A as input and Y or any symbol as output. So this is a revision lah. So since you have one input in digital circuit, you can have either 0 or 1. Okay, Lee Moon Hang.
Yes, Doctor.
So when you have input 0 for inverter, what is the output?
1.
1. When you have 1 as input, the
0.
output will be 0. So do you know why this happened?
Because it is an inverter.
So you understand based on the transistor. Is it like that before?
Huh?
How do you understand that? When you give 0, you'll get 1. When you give 1, you'll get 0.
This one
Macam mana you tahu? Because maybe for inverter, it's easy for you to remember lah. It's just the other way around, and they're opposite.
Yeah.
But can you understand based on the transistor or MOSFET connection?
No, Doctor.
Oh, okay. It's alright. I'm going to explain this. This is very important. If you don't understand, let me know.
Okay, Doctor.
So for
Thank
this, okay. I think inverter you boleh hafal lah. Even NAND gate, NOR gate, you can hafal. But as I said, this is about understanding lah. Kalau you faham any circuit, you can understand lah. So when you give 0, your output will be 1. Why is it? So look at this. Actually, it is in your slide lah. I just redraw. When you have A input, Y as output. So let's say we put 0 as input. So both transistor will receive a voltage. I can say a voltage ataupun input saying that this is 0. Sebab dia connected. Dia akan divide. A ni divide kedua. So atas ni yang ada bubble, your transistor that got small bubble, it's either you draw inside or not, tak kisahlah. Yang penting ada bubble. So this is a PMOS. Even definition of PMOS pun ada debatable tapi nak selamat saya kata this is a P channel lah. This is a P channel MOSFET. And bawah ni, this is a NMOS or N channel MOSFET. Before this on the previous slide yang tadi transistor act as a switch, kita ada tunjuk when you give G0, G1, what will happen? I believe if I ask you, some of you still tak faham saya rasa, but in this case I'm going to explain it slowly so that you can understand. When you give 0, what will happen to PMOS? Siapa? Lee Moon Hang.
Yes, Doctor.
When you give 0, okay, to P channel, what will happen? Is it going to turn on or turn off?
Give 0 to P channel. I'm not sure, Doctor.
Not sure. Okay, you go back to slide 10. Boleh?
Okay. Ya,
Okay.
boleh.
for N channel, if you give 0, what will happen?
It will be open.
Your transistor will be open.
For N channel.
Open means turn off lah.
Yep. Turn off. Yeah.
Okay. So that's why I said I'm going to repeat this again. In this case, they give G0 and G1. But if you learn about, I think in your chapter 2 or before this, you have learned about transistor. So since dia ada ni sikit lah, G0 tu maksudnya dia bagi low, bukannya bagi voltage 0. Don't get confused lah. Maksudnya you boleh kata dia tak bagi, dia bagi negatif. Dia banyak lah definition kat sini. Macam ni maksudnya for N channel, you must understand that you need a voltage. So ataupun your input must be high to make sure that the transistor is on. Tu faham tak? Kan betul Kalau you tengok NMOS, okay, dekat slide 10 you tengok NMOS. Semua refer slide 10, you ada NMOS and PMOS. So you have NMOS above, PMOS below. So and then on the right dia tulis G0 and G1. So what will happen to them lah? If you put G0, dia akan open. Open means dia turn off. Dia terbuka. Your circuit is open. When you put G1, your transistor is closed ataupun turn on. So you must understand the reason G0 is means that dia tak sampai threshold voltage lagi, you punya voltage tu. Less than threshold voltage. So your transistor will never on because the channel is not formed. But when you give G1 in this case, maksudnya bukan bagi 1 voltage dia bagi high lah, maksudnya dia bagi voltage yang enough for your transistor to turn on. So in this case, when you give G1, your transistor will on. Is it okay, Lee?
Yeah, okay.
So okay, I'm going to ask you again. When you give, I give you when you have input 0 for inverter, for PMOS, what will happen? Is it going to turn on or turn off?
For 0, it will turn on.
So your transistor will turn on. What will happen to NMOS when you give 0?
Turn off.
So it become your NMOS will turn off.
Yeah.
Right. Okay. So that's why you'll get output as 1 because only transistor above, your PMOS is turned on and the current will flow from VDD to output. And there is no current go to the ground. There's no current here. So you got high. 1 here is VDD, which is high. Depends lah if it is, you define VDD as 5 volt. So that is 5 volt lah, high. Is it okay?
Yeah, okay, doctor.
So this is actually, rather than you memorize when you give input 0, 1, you must also know how to explain this one lah.
Yeah.
So, okay, thank you.
Okay, thank you, doctor.
So I'm going to explain the other way around. When you give 1, what will happen to your output? So you know that you boleh hafal easily you punya truth table, but for the objective of this subject is for you guys to understand what happened to the circuit. So I'm going to redraw the circuit again, the circuit for inverter. But in this case, you have input of 1 instead of 0. Just now kita tahu lah kalau inverter letak 0 jadi 1. Tapi why does it happen? Okay, Lee Si Lian.
Yes, doctor.
Okay, when you have input 1 ataupun high, what will happen to your PMOS ataupun P channel transistor above? Is it going to turn on or off?
If it is 1 through the PMOS, it will be turned off.
Okay, so your PMOS can turn off. So what will happen to your N channel or NMOS when your input is 1?
Turn on.
So it will turn on. Turn on. NMOS. So when this happen, means that the current can flow from ground to the output. So that's why you'll get output of 0. And there's no current flowing from VDD to the output. Is it okay, Lee Si Lian?
Yes.
Okay. So this is very important because after this we're going to do the same thing, but for NAND gate and NOR gate. So if you go to slide 12, so all the explanation is there. So I'm going to turn to my lecture notes. Okay, can you guys okay, let's go to page 12. So this is the explanation what I did before. So when you have an input logic of 1, is it 11? Start from 11. Okay, 11, this one inverter. So page 12, when you have input 1, your P channel will turn off. Your N channel will turn on. So that's why you get 0 as output, low. And then when you give 0, it is the other way around. Your P channel akan turn on, but your N channel akan turn off. That's why the output is pulled high. So dia punya ayat kat atas tu pull down or pull high lah. Kalau P channel is pull high lah. Maksudnya your output akan jadi high. In this case high adalah 1. Okay. Okay, next we're going to combinational circuit. So kita akan belajar lagi advance lah, more transistors. But before that, I think we're going to have about 5 minutes. Rehat, is it okay? If you need to go to toilet, maybe wash your face, ngantuk ke apa. So meet you another 5 minutes. Is it okay, class?
Okay.
Okay, so 5 minutes. Okay, class. Let's continue our class. How many participants we have? So we have 54. And in your attendance, Sia Yok Kit, ada tak? Sia Yok Kit. Ada Muhammad Amirul Haris.
Ada.
Ada, you tak sign lagi
Belum.
Jangan lupa. Dan Muhammad Hairul Ikram. Ada, kalau tak ada WhatsApp dia suruh ni. Muhammad Fikri. Ada, tak ada juga. So those are missing Ada Anwar Faiz, Sia Yok Kit, Muhammad Amirul Haris, Muhammad Hairul Ikram dan Muhammad Fikri. Muhammad Fikri bin apa ni? Muhammad Fikri. Okay. Alright, let's continue. So go to page 14. Combinational logic. So just now we've learned about inverter. Saya kata if you understand about inverter, the rest should be okay lah. So inverter is using only one transistor pull down and one transistor pull up. Bawah N channel, atas P channel ataupun PMOS lah. So how if you want to use more than one transistor? So of course you're not just going to design an inverter. You also need to design something else. So there are fundamentals, orang kata apa, rules ataupun things that you need to know lah. Okay, first if you look at the slide, when you have two switch that are placed in series, you tahu lah, you have learned about series circuit before. If you want to make it turn on, you have to make sure that both transistors are on. So in this case, it is N switch, maksudnya N channel. So you have to set it high lah. You have to set it 1. And it will become like N gate. Betul tak? Kalau N, both input must be high lah in order to get high. Okay. Boleh So next. This is example lah kalau in the figure. Boleh nampak you ada source to drain. And in between you have G1 and G2. So this is AND gate lah actually, because AND gate both input must be high in order to get high for the output. Okay, next, if you have two P switch that are placed in series, macam dalam gambar ni, you ada dua P transistor yang ada dot to P, ingat dia connected in series. So to make sure that these two are on, you must set the input to 0, or accurately you must set lower voltage lah, because P channel atau PMOS dia mesti less than 0 lah in order to get to turn it on. So your input must be 0, maksudnya low in this case. So in this case dia juga adalah N, connected in N, but dia ada bar lah because this is a P type ataupun P channel. Next, if you have two N switch, two N transistor that are placed in parallel. Kalau dia ada in parallel macam mana? So you to make sure that it is turned on, all the whole circuit is on ataupun connected, you just need to turn on either of the circuit. Kalau ada dua, salah satu must be on, you boleh make sure that dia punya connection to source to drain is connected lah. So in this case, it is equivalent to OR gate lah, A plus B. Maksudnya, if you have two input, one of them high, you can get the output high lah. Alright, next is two P switches are placed in parallel. When we have two P switches that are connected in parallel, in order to make it on, either of the switch must be set to low. So this is also OR gate lah, but in this case, since it is a PMOS, you must have bar lah. A A apostrophe tu is equivalent to A bar lah. P apostrophe is equivalent to B bar because of P channel. Okay. So using this construction ataupun this law ataupun this understanding, you can design any CMOS combinational gates as long as you follow these rules. So next we go to NAND gate. Is there any question before we go to NAND gate? Ada soalan tak? Kalau okay, saya akan go faster. Kalau ada masih tak clear, I have to slow it down. Boleh Alright. So for NAND gate, when you have two input of NAND gate, when both input are 1, the output is 0. That is the truth table. So in this case, you use series pair of AND switch with one ended connected to ground and the other one is to the output. Faham tak? You know that NAND gate, both input, whenever the both input are high, the output must be low ataupun 0. So how to do that? You know that kalau high, yang boleh turn on adalah N channel. So when you have a series of ataupun pair of N switch that are connected in series, you can connect that one from ground to output. So you can have this output. So in design circuit, you need to know the behavioral. Ni macam mana behavioral dia, maksud you nak dua input, kalau high dia akan bagi low which is ground lah. So you can have two N channel ataupun two N switch in series. Okay. So since you know that one, for the pull up tree ataupun pull up punya connection, you must have the other way around, complement. So your P switch must connected in parallel. So one end is connected to VDD and the other one is connected to output. Because when you give one, they akan turn off lah for P channel. So since you know these two network, pull down and pull up, we just combine these two. Pull down, go down, pull up, go up. And you can have a connection just like in the figure lah, in page 15. So this is the equivalent circuit for NAND gate. Is it okay, class? Malinda?
Ya, saya.
Boleh?
Boleh.
Faham Ada soalan tak?
Doktor yang apa ni, P-type tu, dia sekejap, P-type
P-type ke PMOS masuk P channel lah.
P channel. Yang itu dia jadi kosong kan? Ke satu?
Untuk kes apa?
Oh, okey, saya dah faham.
Okay, boleh
Okay.
Tak apa, lepas ni kita go balik. Alright. So in this case, as a conclusion, an input NAND gate constructed by placing N switches and P switches connected like this lah in this slide. If you look at if you learn about K-map before, coordinate map, you boleh groups the one and you can get sum of product, SOP of A bar plus B bar. And you group the zeros, you akan dapat product of sum of A dot B. So this is the function lah. In other way, you boleh look at K-map punya ni lah. Alright, so that one is for NAND gate. So when you have a truth table, you know that when you have two inputs, there are 4 possibilities. It can be 0, 0, 0, 1, 1, 0, and 1, 1. So the connection must be like this lah, just like we discussed before. So N channel ataupun NMOS which is pull down must be connected in series, and your P channel ataupun P MOSFET must be connected in parallel. So in this case saya tunjuk satu. So slide 16. Let me share the whiteboard. Let's have a look. When you give 0, 0, what will happen? Saya buat memanjang lah lecture notes saya. Continue down. Okay, first I will redraw the circuit for NAND gate. So you're going to have 2 transistors for pull up and 2 transistors for pull down. So for pull up, remember PMOS must have dot. And your N channel must be connected in series. And pull down must be connected to ground. So your pull up must connected to VDD. So you have one output which is Y in this case, and you have 2 input A and B. So this one is A, this one is B. So B can also go here, and A can also go here. Okay, let's say when you have 0, 0, your input are 0 for A and 0 for B. Okay, let me ask someone. Mazratul Mazida. Mazratul Mazida. Ada tak? Mazratul Mazida binti Muhammad. Apa ni tak nampak? Tak ada Miza Nabilah.
Ada.
Okey. Sekarang kita ada circuit kan? Circuit apa tu?
NAND gate.
So this is NAND gate Sekarang awak faham tak kenapa circuit tu macam ni?
Sebab
Boleh?
N channel series dengan P channel parallel.
Macam mana boleh dapat macam tu?
Yang tu tak tahu.
Tak tahu Saya dah explain tadi tu lah. Okay, tak apa. Sekarang ni apa okay, tak apa. You assume mungkin you dah tahu circuit ni Nanti saya akan explain balik yang tu. Sekarang ni truth table ni you tahu tak? Kalau NAND gate Miza?
Tahu.
Okay, ada A, B. Kalau 0, 0 apa output dah?
1.
Okay, output Y 1. Kenapa 0, 0 jadi 1?
Sebab AND gate lepas tu dia ada inverter.
Okay, that is what you learn before lah kan? So you ada AND gate, so nak ingat senang lah, ingat AND gate, N 0, 0 akan jadi 0. Lepas ada inverter, you invertkan dia jadi 1, betul tak? But you need to understand on circuit basis macam ni lah. Kalau guna circuit ni, itu that's why I kata tu teori saya nak tahu sekarang ni apa yang jadi reality dia sebenarnya. Kenapa 0, 0 you can get 1? Tu boleh tahu tak Miza?
Yang tu tak tahu.
Tak tahu. Yang inverter tadi dah tahu tak?
Yang 0,0.1 ke? Yang tu tahu.
Dah faham Kalau faham tu you patut faham ni. Okay, let's do together Miza, awak jawab soalan ni. Kalau you ada input 0 untuk A dan input 0 untuk B, what will happen to your NMOS Dia turn on ke turn off? Dekat whiteboard saya ni. So,
Sekejap,
yang bawah adalah NMOS. Atas PMOS. Pun dia boleh panggil pull up atas, bawah pull down So pull down semua NMOS lah. You tak boleh mix So NMOS dia akan on ke off kalau you bagi 0?
Turn off.
Okay. Kalau NMOS you bagi 0, dia akan turn off. Okay. So ni turn off. So since you ada dua in series, kalau salah satu dah turn off tu semua turn off lah. Betul tak?
Betul.
Okay. How about PMOS? Kalau you bagi 0,
turn on.
So dia akan turn on. So both transistor on the pull up pull up tu yang belah atas, network yang atas tu akan turn on. So there is a connection from VDD to you punya output, which is Y lah in this case. So maksudnya dapat voltage dia high lah. So your output will become berapa? Miza, 0 or 1?
Yang untuk P ke?
Untuk P, yes. Untuk keseluruhan ni lah.
Jadi 1.
Jadi Y. So Y, Y tu apa? 0 or 1?
1.
So jadi 1. Okay, faham?
Faham.
Okay. You boleh explain tak dekat saya untuk 0, 1. When you have input yang 0 dengan 1. 0 untuk A, 1 untuk B.
Kalau 0 untuk A, PMOS dia jadi turn on.
PMOS jadi turn on. Okay.
Lepas tu kalau B dia 1. Sekejap terbalik.
Apa? You jawab macam ni. Mula fikir NMOS dulu. Okay, pull down dulu. Kalau A0, B1 apa jadi dekat transistor tu?
Jadi on.
Kalau A0, NMOS bawah ni on ke off?
Off.
Off. Untuk B?
Untuk B dia on.
On. Okay. Apa jadi dekat PMOS pula untuk A dengan B? Kalau dia 0 and 1.
PMOS kalau 0 dia on, kalau 1 dia off.
On, 1 dia off. Okay, sekarang situasi macam ni, in this condition. Okay, let's look at the pull down. Pull down tu yang output ke bawah, yang NMOS saja Faham Miza?
Faham.
Okay. Now you ada series betul tak? Transistor yang series channel. Satu off, satu on.
Akan on.
Dia akan ada connection ke tak ada ke output?
Tak ada.
Tak ada sebab salah satu. Dia kena dua-dua. Yalah, you ada in series kan, bersiri. So satu tak ada, dia akan terputus lah. Tak kisah satu lagi tu on ke off. Okay, so maksudnya of course dia bukan 0 lah. Kita dah tahu 1. Tapi kita tengok balik ke atas lah. Yang pull up tu, we have two transistors, PMOS. Satu on, satu off, betul tak? But since this is in parallel. Kalau parallel, VDD tu nak turun satu transistor, alamak off, dia boleh pergi satu lagi transistor, tu on. Dia ada dua jalan. Boleh. So the output will become?
On. One.
On lah Okay, that's why kalau 0, 1, you akan dapat?
1.
1. Okay, boleh faham?
Okay, boleh.
Okay. Okay, thank you. Muhammad Afham. Muhammad Afham. Ada tak Muhammad Afham? Dah ready nak pergi sembahyang Jumaat ni apa ni? Muhammad Faiz. Muhammad Faiz bin Norman.
Saya.
Okay. Boleh tolong? Kalau you ada input A 1 and then B 0.
Terbalik ya macam tadi.
Senang jawab terbalik tadi. So kalau 1 dekat A, dia apa jadi dekat NMOS? On ke off?
Dekat NMOS kalau 1 jadi ke? Hello.
Ya.
Dekat A kalau 1
Kalau 1 apa jadi?
Ah,
Sekarang kita cerita pasal pull down dulu pull
okay.
down.
Dekat PMOS tu jadi off. Dekat NMOS jadi on.
Kalau 1 NMOS jadi on ni on So kalau A 1 NMOS on ke off?
NMOS jadi on.
Okay, kalau 0?
Kalau 0 dia off.
Off, okay. Kalau PMOS pula, kalau 0?
Kalau 0 dekat PMOS tu jadi on.
On. Kalau 1?
Dekat NMOS jadi 0. Off.
Jadi off lah. Tadi saya terbalik apa ni?
Terbalik.
Connection saya tu apa? MB ni kat bawah. Sorry So tadi patutnya yang belah kanan tu on, kira off lah. Tapi anyway result dia sama lah. So in this case, so untuk ground ke output, no connection lah because one of the transistor is off. But from VDD to output, you can have one way ni lah, satu jalan kat sini. This one tak boleh kan, tapi still ada connection from VDD to output. So your output will become berapa Faiz?
1.
1 Alright. Thank you. Next Muhammad Syafi. Muhammad Syafi. Ada? Tak ada, lagi masjid lah. Jadi Muhammad Afham ada lagi tak? Afham Syafi. Muhammad Karil.
Ada saya ada.
Siapa? Siapa yang ada ni? Afham ke Syafi ni?
Faham.
Afham, okey. Awak explain kat saya kalau you ada input satu untuk A dan B, dua-dua satu. So what will happen to NMOS first?
Rasa. P channel off.
Kalau satu, tak N channel sebenarnya, NMOS.
Sorry.
Kita buat bawah dulu.
On.
Dia kan on. Kalau B1?
On juga.
On juga. Okay, let's go to pull up. Kalau B1?
Off.
P transistor akan off. Kalau A1?
Off.
Off juga So since kalau yang atas pull up ni dua-dua off. So there is no way for VDD to flow from ni lah through the transistor go to the output. So the only way is from ground to the output. So the output will become berapa? Siapa tadi? Afham. You punya output akan jadi
kosong.
Kosong lah because they go to ground Okay, so hopefully you guys boleh explain macam ni lah not only just memorize your truth table, but you can also explain using schematic transistor like this. So in this case, if you understand about CMOS NAND gate, it will be exactly the same untuk NOR gate. Okay. Sekejap Hello. Salam. Ya, adakah kenapa tidak boleh? Okay, next we go to NOR gate Muhammad Khairil Azwan. Ada, tak ada?
Hello.
Hello, ada?
Ada.
Okay, so untuk NOR gate macam mana? Untuk NOR gate, you punya pull down kena transistor yang connected tu apa?
NOR gate pull down tu yang N channel CMOS.
Must be N channel. Yalah, N channel, betul lah. N channel So you punya pull up?
Pull up pula P channel CMOS tapi connected in series.
Okay. You faham tak kenapa jadi macam tu?
Kot.
Firstly, macam ni tau you kena imagine sekarang ni you tak tahulah. Circuit ni you tak tahu. Tapi at least you tahu dia punya behavior. Maksudnya kalau 0, 0 berapa let's say A, B and Y. Sekarang ni kita tak tahu circuit lah kita nak design circuit NOR gate for example. You beritahu saya kalau 0, 0 NOR gate jadi
0 NOR gate jadi 1.
1. Kalau 01?
01 kosong.
010?
Kosong.
1?
Kosong.
Kosong Sekarang ni kan kita tak tahu circuit tu macam mana, tapi kita tahu rules tadi. Kalau 0, 0 mesti 1. Macam mana tu? Nampak tak idea dia? So maksudnya 1 kat sini saya tanya awak Khairil Azwan, kalau 1 kat sini high maksudnya transistor apa? Pull up ke pull down yang working?
Transistor pull up.
Yes.
Sebab
nampak
dia macam
sekarang you imagine you tak tahu circuit sekarang. Supaya you tahu pull up mesti orang kata apa? Mesti on. So macam mana tahu? So sekarang ni you ada 2 possibility, sama ada in series atau parallel. Tapi since you punya input mesti sama, sebab kalau salah satu 0 pun dia tak jadi 1, so maksudnya dia mesti in series.
Betul.
Faham tak? Betul kan?
Faham.
So once you dah tahu untuk P channel, since this is a good thing about orang kata apa, CMOS lah. So untuk designer dia senang, dia just think about one network. So you dah tahu P channel tu, then dia punya N channel must be opposite. Kalau dia series dia mesti jadi parallel. Boleh?
Boleh.
Okay, faham So now you boleh come out dengan you punya schematic circuit sendiri lah. Kalau let's say saya bagi you satu table, any table you can come up with a schematic. So your exam will be like that lah, in your final. Is it okay?
Okay, Doctor.
So I think I don't have to explain one by one lah untuk CMOS NOR gate. But let's say if there is a request next week lah, saya akan go balik lah one by one. But basically the same thing lah. I think kalau those yang faham akan boring lah. I keep repeating the same explanation. And for this chapter, that's why saya boleh habiskan hari ni. Dah pukul apa? Almost 12. What you need to prepare lah for your exam test or whatever lah untuk for exam any evaluation. How to do compound gate lah. Macam just now inverter, NAND gate, NOR gate. Okay, tu memang you dah ada knowledge lah. Okay, ni you just pick any equation. You boleh tanya kawan kamu lah, bagi satu any equation yang involve. I think for your exam we are up to 4 input ataupun 5 lah, takkan jadi 10 input lah. Bagi satu Boolean equation, you have to come out with schematic diagram. Okay. So you need to understand until that level. So you can go to compound gate. In this case, they explain about A dot B plus C dot D and then ada bar atas. So how are you going to come out with a circuit? So let's say you understand that one, you can continue with another example which is A plus B dot C dash and so on lah. So try this at home and then look at the exercise and I'm going to ask you about the exercise next week lah. Is there any question? Ada soalan apa tak? Semua okey? Semua faham Okay, another thing untuk you punya assignment I think since in one day I can finish one chapter, I believe in next week one day saya akan habis satu chapter jugalah. So we're going to spend more time on the cadence but the problem is I don't know why when I cannot connect to the we call that server lah. So I'm going to figure it out. I've asked the technician, but unfortunately the technician is off today. Maybe next week I can figure it out. But I think the important thing is you guys to come out. You have 5 group. First, I'm going to ask the list member of your group, and I also want you guys to come out with a circuit. So you ada almost 5 times. You have 12 groups. So your circuit must be different from each other. Don't simulate the same circuit. And then you must have a plan. Let's say you have one circuit. The simplest example I can say is adder. You cari adder. Jangan semua buat adder pula. So that's an example lah. Jadi adder is using CMOS technology. Not using any transistor lah. Menggunakan CMOS maksudnya dari complement. Let's say find that one. And then come up with the advantage. Actually, you dah dapat tak assignment punya paper tu? Belum lagi I think Dr. Faiz akan share in the ni lah. Julian ataupun saya akan share dalam WhatsApp group. So there are a few things that you have to take note lah. Let's say you take this circuit and what is the advantage you can explain lah. And then how you going to analyze? Let's say you can draw. You dah tahu you're going to use 6 or 8 transistors. You're going to make an adder, for example. So you can susun you can arrange it and make the connection pull up, pull down. Okay, so what are the inputs that you're going to have lah? Let's say kalau counter normally you can have ni lah 0 0 what will happen what are the inputs? So you must also think about what kind of analysis that you're going to do for the assignment So that's the analysis can be normally people can give signal wave ataupun in digital form. You can also have a sine wave. You can put a sine wave and see the output. What are the outputs? So, but important is please give me the list. I'm going to remind you ataupun I'm going to give you a form. You guys to fill it up so that I know how many members in your group, and then come out with the circuit. So just Google it. Find in the paper. The preferably is ni lah IEEE paper lah, but if you couldn't find it, it's fine. Just any circuits that are using CMOS technology, means that you're using PMOS and NMOS at the same time. My advice is not to take like too many transistors lah. Sometimes when you have an amplifier, for example, class B, dia ada yang more than 20 transistors, so don't go that hard lah. So try around 10 lah, 5 both and 5 below ataupun not more than 20 lah, so that you can get the results. So since Cadence, I don't know why we cannot use it remotely, but if you want to try it to use it at the lab mine also can lah. Just let me know, or you can ask permission from the technician lah. So it's better for you to do like that lah, because sometimes when you use internet connection, there will be a lot of problem lah. So IP address kan boleh seorang guna. So we have 10 license. So at least maybe lah one of your ni lah wakil group can come and see me. One day I'm planning to show you lah how to use it lah. Like hands on, we have a small class backup, but all of you gonna attend at the same time lah. So at least one wakil from group. But the most important thing is now we have to prepare lah, just like your PSM lah. Just do some literature review, find a good circuit to simulate. So the best way is you go until layout lah, but I'm afraid that you don't have enough time for that one. But just go for the schematic analysis ataupun simulation. That will be enough lah for your assignment. You're going to learn a lot from there lah. And then this is also be a good experience and opportunity for you guys if you're interested to become a IC designer. For example, banyak company nowadays semiconductor, you don't have to go to fab lah. You just work from home, just designing circuit. But you must familiar with software lah, so you can put down in your CV as well. So you have to learn how to design circuit. Companies like, of course lah, Mimos, Silterra, all the semiconductors company, they're going to have a circuit designer lah. So if you know how to design a simple, let's say simple IC design, digital circuit, that will be a good point for your ni lah, in order for you to find a job. I think that's all for today lah. Is there any question before we end our class today?
No, that's all.
Alright. Okay, I think that's all for today. Okay, thank you very much for attending the class. So see you next week lah.
Okay, that's all.
Okay.